In previous lecture, we discussed large sample test for single proportion. In today's lecture, we will discuss large sample test again, but now instead of single proportion, it will be discussed for difference of proportions, that is difference of two proportions. We talk over large sample test for difference of proportions in certain detail. Certain background is to be discussed before discussing anything. Like here, suppose we want to compare two distinct populations. If you remember, in previous lecture when we discussed large sample test for single proportion, there was only one population containing n members. Here we have two distinct populations. That's how the difference of proportion will develop with respect to the prevalence of a certain attribute. Whatever the attribute is given, whatever the requirement is given, say A, among their members, means among members of these two populations, let x1 comma x2 be the number of persons possessing the given attribute A. They are following that given attribute A in random samples of sizes n1 and n2 from the two populations respectively. That means in first population n1 people are there, and out of that x1 are possessing a certain attribute A, while in other population n2 people are there, and out of that x2 people are possessing that same attribute A. Then sample proportions are given by small p1 is first proportion and small p2 is second proportion. How? X1 out of n1 are following attribute A, so ratio or proportion is x1 upon n1 defined as small p1 and x2 upon n2 defined as small p2. Now if we assume that mean or expectation of small p1 and p2 are capital P1 and P2, and variance of small p1 and small p2 are capital P1 Q1 upon N1, capital P2 Q2 upon N2. These are standard symbols, standard definitions given for two samples. Whenever we talk about two sample sizes having N1 and N2 people, then these are the standard results for that. Now, since for large numbers P1 and P2 are asymptotically normally distributed, as we know, large sample, in case of large sample we follow normal distribution. In fact, in last lecture we discussed binomial distribution was tending to normal distribution for a large sample test for single proportion. Okay, now as we have to talk about difference of proportion, that means difference of small p1 and p2. So p1 minus p2, as p1 p2 simply or single proportionally are also normally distributed, so difference of two normal distribution is again a normal distribution case. So p1 minus p2 is normally distributed, and standard variable, as we know, z equals to x minus mu upon sigma. From the beginning of normal distribution we know about this formula. So z equals to x. In case of x we have difference of proportion, that is p1 minus p2, minus mu, mean means expectation, the expectation of x, that is p1 minus p2 here, so minus e p1 minus p2 upon sigma means standard deviation, means root of variance, so root of variance of which variable, p1 minus p2. So that is about initial form for formula of z. Now we will calculate these all things to find final formula for that is standard normal variable z. Now in last lecture we discussed two hypotheses, null hypothesis as per the given statements in the problem, and alternative hypothesis, that is if null hypothesis is not true then alternative hypothesis can be taken. Here we take null hypothesis H0, symbol H0 is always there given for null hypothesis. Under null hypothesis we assume that there is no significant difference between the sample proportion, that is mean of first and second sample are identically same or approximately identical. By doing that under null hypothesis, because if you see the problem or in next lecture when we will discuss problem, we will see that under null hypothesis p1 and p2 will be approximately identical. So here we are taking that, and as there is no significant difference between sample proportion and EP1 minus B2, what we have to calculate to find Z? And using the formula of expectation, ex1 plus x2 is always written as ex1 plus ex2, as my sign of negativity is there, so it's ep1 minus ep2. And we know that ep1 from that standard formula capital P1 and ep2 means capital P2, so it's capital P1 minus B2. Under null hypothesis we are assuming capital P1 P2 are same, so it is 0. So ep1 minus P2 means that term become 0 under null hypothesis. Now formula of variance, standard property of variance is applied here. Vx1 minus x2 is always equal to Vx1 plus Vx2, so Vp1 plus Vp2 here, and formula of Vp1 and Vp2 standard formula taken from there. And then why it is written in that form? Because under null hypothesis at 0 we assume that P1 and P2 are equal. We are assuming that both are equals to P, capital P. And similarly Q1 Q2, which are failure cases, P1 is Q1 is 1 minus P1 and Q2 is 1 minus P2. If though both are same to P, then Q1 Q2 equals to Q. So using that, it is PQ upon N1 plus PQ upon N2, that is PQ taken as common, into 1 upon N1 plus 1 upon N2. So using that formula of Vp1 minus P2 and EP1 minus P2 equals to 0, in that equation Z is finally defined as P1 minus P2 minus 0 means P1 minus P2 upon root, that variance is PQ into 1 upon N1 plus 1 upon N2. And that is one very important formula which we have to remember. Okay, I'm not discussing too many theoretical background there, but you have to remember formula of that P1 equals to P2 equals to capital P, which we assumed under null hypothesis for difference of proportion case, large sample test for difference of proportion. Remember that capital P is equals to N1 P1. What about N1 P1? It is nothing but x1 actually. N1 into P1 means x1, so it's x1 plus N2 P2 means x2 upon N1 plus N2. That is sum of both sample which are possessing sample people which are possessing the given attribute upon sum of total members of both the sample. And if P is there, Q can be obtained by 1 minus P. So that is about certain theoretical background of large sample test for difference of proportion. In next lecture we will discuss one very important problem regarding the same. We discuss one very important problem regarding that large sample test of difference of proportions. As you can see, random samples of 400 men and 600 women, means N1 equals to 400 and N2 equals to 600, were asked whether they would like to have a flyover near their residence. A certain social kind of problem is there, that a flyover is required or not there near their residence. It is being asked to certain two populations. 200 men out of 400 were in favor of this, and 325 women out of 600 were in favor of the same. Now we have to test the hypothesis that proportions of men and women in favor of the proposal are same against that they are not at 5% level. We will discuss what is written there with that 5% level, etc. in the end of solution of this problem. Initially we began it with that, say, 400 men, so N1 400, 600 women, N2 600. Out of 400, attribute is, like I was discussing in theory in last slide, means attribute is defined here as would anybody like to have a flyover near residence. So 200 men are in support of it out of 400, so capital X1 is 200, and 325 women out of 600 are in support, so capital X2 is 325. Small p1 p2 are defined as we discussed in theory, x1 upon n1, that is 200 upon 400, 0.5, and small p2 is in similar fashion, it becomes 0.541. So it is about initial mathematical formulation of the problem. In next slide we will discuss whole remaining solution, but before that we can talk about the hypothesis in this slide. Null hypothesis H0, under which we say that P1 P2 both are equals to P. There is no significant difference between the opinion of man and woman as far as proposal of flyover is concerned. That is, we are saying that out of all given men, a certain number of men are thinking about supporting this proposal, and out of women, certain number of women. So it is almost similar kind of number. So there is not much difference. That is P1 P2 equals to P. And alternative hypothesis H1 is always against null hypothesis. So in that case P1 and P2 must be different, two-tailed, that is P1 and P2 are two different tails. So we will see which hypothesis is to be accepted finally in next slide with further solution. Now under null hypothesis we know about the formula of Z as per the first slide, theoretical slide of this lecture. And formula of capital P was also discussed there, x1 plus x2 upon n1 plus n2, substituting all the values x1 200, x2 325, n1 n2 400, 600. Finally value of capital P is 0.525 and q is always 1 minus p, so it's 0.475. And formula of Z is there, small p1 minus small p2, so 0.500 minus point, that is about small p1 p2, which we calculated in previous slide, upon root capital PQ, our values defined here, 0.525, 0.475 into 1 upon 400, that is 1 upon n1 plus 1 upon n2 means 1 upon 600. Now certain calculation showing that that value of Z is minus 1.269. Now in the problem as given 5% level of significance etc., we have to discuss a certain critical region. For that 5% level of significance, that is standard theoretical concept which is defined for a particular large sample test for difference of two proportions. It is for that only. Two-tailed test, as you can see, two-tailed test means two proportions and that difference is being discussed. And will it become two-tailed problem or one tail? It's all depend upon that critical region. At 5% level of significance means there are different significance levels defined in statistics. Out of them 5% level is very important, so it is mentioned here. At 5% level of significance, the critical value of Z, it is to be remembered from your side as a formula. The critical value of Z for a two-tailed test, that is for large sample test for difference of proportion, is 1.96. At 5% level it is 1.96 critical value of Z means mod Z, or in next line it will be more clear. Thus the critical regions consist of all values of Z. As critical value is 1.96, so either Z equals to 1.96 or more than that, that is Z greater than equals to 1.96. and it is actually mentioned for mod Z, so from other side it is also obtainable. The Z less than equals to minus 1.96, still mod Z will be greater than equals to 1.96 by that also. So if value of Z is either equals to minus 1.96 or less than that, or equals to 1.96 with positive sign or greater than that, then we say that two-tailed test is required for that. That means H1 will be selected and H0 will be rejected. But if it does not comes under this, then H0 is selected and H1, the alternative approach, is rejected. That means two-tailed test will reduce to one-tailed test. And what was required? It was required to prove in this problem also. So conclusion, mod Z here in this problem minus 1.269, modulus of that is plus 1.269, which is obviously less than 1.96, less than that critical value for 5% level of significance. So it is not significant at 5% level of significance, as H0 may be accepted, as I was discussing just before, at 5% level of significance. And H0 is accepted means there is not much difference between two samples. So we may conclude that man and woman do not differ significantly as regards proposal of flyover is concerned. Almost similar kind of percentage is in support of that flyover as it is concluded finally. So that is about very important problem regarding understanding a large sample test for difference of proportion. Up to this we have discussed large sample test for single proportion and a large sample test for difference of two proportions. We will be continuing discussing this large sample test in several more lectures with different characteristics, and it is over about proportion cases.